Video I will be covering the first topic of EDEXCEL-Math Cambridge IGCSE. It is a relatively easy and short topic just about numbers and fractions, etc. Okay, HCF and LCM, okay, converting fraction to decimal and things like that. Okay, it's basically like a revision from the previous grades and all, so it should be easy. Okay, so yeah, let's begin. So the first lesson is about numbers. Okay, so we're going to be identifying the types of numbers. So we have a natural number first. A natural number is any number initiating from 1 till infinite. So a number that starts from 1 and then keeps going on till infinite. Okay? A whole number is any number that starts from 0 and then keeps going on till infinite. So basically a natural number and a whole number are technically the same thing, just the only difference is that a whole number will start from 0 and then it's going to go to infinite, while the natural number will start from 1 and then it's going to go to infinite. Okay? The integer number, on the other hand, is any whole number that is not fractional, but it can be positive or negative or 0. Basically, an integer number is like a directed number, because directed numbers are positive and negative whole numbers. So yeah, example, -3, -2, -1, 0, 1, 2, 3. You can go infinitely backwards and infinitely forward. Okay. Rational number is any number that can be converted or represented as a fraction. Okay. Example, all real numbers are rational. 9.45678, 2 over 3, -3.4. Okay. So this is a small chart just to explain all the numbers. You're going to start off with the natural numbers, 1 to infinite, then the whole numbers, 0 to infinite, then the integers can go behind 0, okay, like -2, -9, -5, 0, 1, 2, 3, and then rational numbers, any number that can or be represented as a fraction, okay? A quick fact is that whole numbers contains natural numbers, integer numbers, and contains both whole and natural. Rational numbers contains basically everything. Okay. Now we'll have a look at some perfect square numbers. Okay. So what is a perfect square number? A perfect square number is number that is made of two same numbers multiplied together. So if you take two numbers, the same numbers, multiply them together, the product of two same numbers multiplied together is going to be a perfect square number. Okay? For example, 1, 4, 9, 16. All perfect square numbers are rational numbers. Okay? For example, 16 squared will be 4, 9 squared will be 3, okay? So any number that has or can be divided into two numbers that are the same that multiplied together to produce this number is a perfect square number. Okay, now we have three irrational cases in which the number is irrational. This is any square root that is not a perfect square is an irrational. For example, square root of 10, it does not divide into anything that are two numbers that made up are the two same numbers. Okay, so basically these are known as surds. Okay, any decimal that is non-recurring. Okay, so a recurring decimal is basically a decimal with consecutive same numbers after it, like 0.3333, 5.44444, 6.88888. So any decimal that is not recurring is an irrational number. And pi is the last one. Pi is also irrational. Okay? All recurring decimals, just remember that they are all rational. Okay? Okay. Now let's come to multiples. So I'm pretty sure you all know what a multiple is, but again, multiple is multiplying any whole number by another whole number, and the answer is called a multiple of either one of those numbers. I know definition might sound a bit confusing, but just have a look at the example. 5 times 7 is equal to 35. So 35 is a multiple of 5 and 7. Okay? It's a common multiple of both 5 and 7. For example, 2 times 5 is 10. 10 is a multiple of 2 and 5. 3 times 3 is 9. 9 is a multiple of 3. So basically that's it. Now, how do you find multiples of numbers? I've listed two methods here. Either you can use addition or you can use multiplication. Okay, for example, the question is find 6 multiples of 5. Either you can keep adding 5 and just take all these sums and that's your multiples. So 5 plus 0, 5, 5 plus 5, 10, 10 plus 5, 15, 15 plus 5, 20, 20 plus 5, 25, and so on and so forth. Take all these sum of your answers and that is your multiples. Or you can just use the multiplication table 5, 10, 15, 20, 25, 30 up till you reach 6 numbers or 6 digits, and those are your multiples, okay? As easy as that. Now let's have a look at factors of whole numbers. A factor of a whole number is any number that divides into it exactly. So finding factors of whole numbers, we have two main steps to follow. The first one is you check if the given number is divisible by all natural numbers in order, okay? If you don't remember what natural numbers is, it is the first definition we took. A natural number is numbers initiating from 1 till infinite, okay? If the number is divisible, then write the product and continue till required. If it is not divisible, you skip that number and go to the next number, okay? So for example, I need the all factors of 30, okay? So 30, what we're gonna start dividing it or see if it is divisible by all natural numbers in order. Okay, 30 is equal to 1 times 30. Yes, 2 times 15. So basically, 30 divided by 1 is 30. 30 divided by 2 is 15, so 2 times 15. 30 divided by 3 is 10, so 3 times 10. 30 divided by 4, nope. So you skip it, go to 5. 30 divided by 5, 5 times 6. So you basically get the idea, okay? So take the number and start dividing it by all natural numbers in order. The answer you get is the factor you multiply it with, and then by the end, these are all your factors, okay? So factors of 30 will be 1, 32, 15, 3, 10, 5, 6. 1 is always a factor, and so is the number itself. Common factors are just basically factors that are common between two or more different or whole numbers, okay? Like factors of 20, factors of 12. 20 include 1, 2, 4, 5, 10, 20. 12 include 1, 2, 3, 4, 6, 12. So what's common is 1, 2, 4. But this does not mean that you write each number 2 times. If 1 is common, write 1 time. 2 is common, write 2 1 time. 4 is common, write 4 1 time. Okay? And yep. Prime number. Prime number is a number that has only 2 factors that multiply it, okay, itself and 1. All prime numbers are whole numbers. 2 is the only even prime number, and 1 is not a prime number because it has only one factor, which is itself. So again, it's very important to remember these 3 definitions. Prime number is a number that has only 2 factors, itself and 1. 2 is the only even prime number, and 1 is not a prime number because it has only one factor, itself. Okay? So these are the prime numbers until 100. 2, which is the only even, then rest are odd. 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. And as you can see, all of these numbers, if you try to find external factors for them, they only have 2 factors, themselves and 1. Even number and odd number. Even number is any number that divides or is divisible into 2. Odd number is any number that is not divisible into 2. For example, you cannot divide 11 by 2, you cannot divide 13 by 2, you cannot divide 17 by 2. You can divide 8 by 2, you can divide 16 by 2, you can divide 18 by 2. And yeah. Now, how do you calculate or see if a big number is prime? Okay? For example, is 523 prime number? How do we calculate that? Okay? We'll have a look at these 4 steps. First, I want you to take the square root of the given number, which is x, okay? then take all the prime numbers below x, okay? Then divide the initial given number, okay, by all those prime numbers, okay? And then you will end up with two scenarios. If the given number is divisible by any one of those prime numbers to produce a whole number, the answer is not prime. But if the given number is not divisible by any one of those prime numbers to produce a whole number, the answer is a prime number. Okay? Let's have a look at the example now. Is 523 prime number? The first step, take the square root of the given number. Square root of 523 is approximately 22.8. Now I will take all the prime numbers below 22.8. 2, 5, 3, 7, 11, 13, 17, and 19. Now I will divide my initial given number 523 by all of these prime numbers, and depend on these two cases I will determine whether it is a prime number or not. As you can see, the given number is not divisible by any one of these prime numbers, so 523 is a prime number. Squared number, I believe I've explained this before, but why not? The product you get when you multiply any number by itself, any two same numbers together. For example, square of 5 is 5 squared, 5, 5, 25. Square of 6 is 6 squared, 6 times 6, 36. You can write it as 5 to the power of 2, or like 13 to the power of 2, and yeah. You can know if a number is a square or cube by its square or cubic root. Okay, so all perfect squares are square numbers, and all perfect cubes are cube numbers. Sorry about the camera. Alright, now coming to lesson 1.5, product of prime numbers. So in this part we will learn the decomposition of prime factors, okay? So you will be given either a number or two numbers, okay? And you have to basically decompose the number all the way down to the prime factors that made this number up, okay? So you're going to start by taking two factors of the given number, then take furthermore factors of those numbers and continue until you reach the prime numbers. After that, I want you to circle all the prime numbers by the end and multiply all of them together to give the given number. For example, 80. What we're going to do now, we're going to take 80 and we're going to separate it into any two factors that make it up. 80 is 80 times 10. 8 is 2 times 4. 2 is a prime number, circle. 10 is 2 times 5. 2 and 5 are prime, circle. Well, 4 is 2 times 2. 2 and 2 is prime, circle. So 80 is 2 times 2 times 2 times 2 times 5. Or you can write it in index form if it is asked in the exam. 2 to the power of 4 times 5 is equal to 80. Always recheck in the calculator, but basically these are the two ways, okay, in which you can write the product of prime numbers. And like I said, this process is known as decomposition of prime factors. And we will be using this method to calculate the HCF and LCM. So, what is the HCF and LCM? Well, let's start with the HCF. HCF is the highest common factor, basically the largest common factor that lies between two numbers, okay? How do you find HCF? So I will be explaining how to find HCF via two methods. During the main explanation, we will learn how to find HCF via Venn diagram and LCM via Venn diagram. And by the end of the explanation, when we reach the questions, I will also explain how to find them using the power or index methods, okay? So let's have a look at how to use it via Venn diagram. So basically, first I want you to write each number as a product of prime factors. You're going to be given two numbers in the question. Write both of these numbers as a product of their prime factors, okay? After that, find the prime factors that are in common to both numbers, okay? So after you have two numbers, okay, you will find that there are some prime factors that are common in both, okay? Find those, okay? Then use a Venn diagram, looks something like this, and put all the common prime factors in the center. all the common prime factors between both numbers should be in the center, and the others will go in the relevant circles, okay? HCF, your highest common factor, will be the product of all the numbers in the center. So the multiplying all the numbers in the center is your HCF. Multiply all the centers in the number to get the HCF. Okay? That's how to calculate your HCF. Now let's have a look at how to calculate your LCM, and then we'll take a quick practice question to end this topic off. LCM is quite simple, okay? I want you to imagine as if we are continuing from the previous example, okay? You already have your Venn diagram, okay? And you have already placed your common numbers in the middle and the relative numbers in the circle. Now, LCM is basically the product of all the numbers in the Venn diagram, the center numbers, the left numbers, and the right numbers. Multiply all the numbers in the Venn diagram, and that is your LCM, lowest common factor. Sorry, multiple. Now let's have a beautiful example to see how do we actually find this. Calculating HCF and LCM, okay? Sorry about the camera. Find HCF and LCM of 72 and 80. Well, decompose both into their prime factors. 72 is 6 times 12. 6 is 2 times 3, prime prime. 12 is 3 times 4, 3 prime. 4 is 2 times 2, 2 and 2 prime. Now 80. 80 is 8 times 10. 8 is 2 times 4, prime prime. 4 is 2 times 2, prime prime. 10 is 2 times 5, prime prime. Okay? Now, have a look. What are the common ones in between? Okay? You can, I think personally my advice is that if you want to make it easier for yourself, write the numbers up and down and write it via their common factors, or like their decomposition of multiples. So basically 72 is going to be 2, 2, 2, 2, 3, 3. Okay, 80 is going to be 2, 2, 2, 2, 4, 5. Alright, now just cancel each one out that is in common. So we have 3 2's in common, so 3 2's are going to go in the middle. And then we have 3 and 3 in 80, and we have 4 and 5 in 72. Okay, so now in 72, on 72, you're going to find 3 and 3, and 80, you're going to find 2 and 5. From here then, multiply everything in the middle to get your HCF, which is 8, 2 cubed. Multiply everything in all the numbers in the Venn diagram to get your LCM, lowest common multiple. A quick tip, the two given numbers, 80 and 72, have the same product as the product of HCF times LCM. So multiply your HCF and LCM, and the product should be the same as 80 and 72. For example, 72 times 80 is equal to 5760. 720 times 8 is equal to 5760. This means your calculation has been done correctly. Okay? If you want, you can use another method to find the HCF and LCM. For the HCF, you can take the lowest powers, and for the LCM, you can take the highest powers. And that will also help you to find the HCF and LCM. And basically that is it for topic 1, Foundation in Edexcel Math, Cambridge IGCSE. If you have any questions for this topic, though it was quite easy, I would be more than happy to answer you in the comments below.